Welcome to our session on course mapping and sequencing in higher education. In this presentation, we'll explore why intentional curriculum design matters, how to align objectives and assessments, and practical strategies to guide students from foundational knowledge to advanced application, all with the goal of improving learning coherence and graduate readiness. This presentation covers an introduction to course mapping and sequencing, frameworks for curriculum design, ways to identify learning objectives, and approaches for structuring course content and assessments, followed by sequencing strategies, challenges, and case studies to illustrate practical implementation across programs. Course mapping creates a clear framework by organizing learning objectives, content, and assessments so courses align with program goals. It helps students reach meaningful milestones, and it provides transparency so both learners and educators share expectations and a roadmap through the curriculum. Effective course mapping rests on a few core principles: alignment to ensure objectives and assessments are connected, progression to build complexity gradually, a student focus that centers learning needs, and collaboration across departments to create coherent, interdisciplinary experiences that support sustained learning. Sequencing affects logical flow, skill development, retention, and overall academic success. Structuring courses to build prerequisite knowledge first, revisit key concepts, and intentionally prepare students for capstone work reduces gaps and supports long-term mastery and practical readiness. Competency-based frameworks prioritize skill alignment with industry needs, allow individual pacing, emphasize practical application through real-world tasks, and use assessment as ongoing learning to ensure students demonstrate mastery in contexts that matter for their chosen fields. Outcomes-based education starts with clear, measurable learning outcomes and uses backward design to align activities and assessments with those goals. This approach supports flexible teaching methods while maintaining quality assurance through transparent tracking of whether outcomes are met. Applying Bloom's taxonomy to sequencing helps define learning progression from remembering and understanding through analysis and creation, set clear milestones for student growth, ensure cognitive depth in assessments, and design holistic courses that integrate cognitive, psychomotor, and affective development. Establishing core competencies means defining foundational knowledge students must master, prioritizing transferable skills like critical thinking and communication, and embedding ethical awareness so graduates not only perform technically, but also navigate professional and societal responsibilities. Aligning course objectives with program goals builds curriculum cohesion by making individual course aims contribute to broader outcomes, focusing on measurable student results, and creating feedback loops that use assessment data to continuously refine course-level objectives and overall program quality. Linking objectives across courses involves sequencing foundational units, so later classes build on prior learning, encouraging interdisciplinary connections to deepen comprehension, and reinforcing skills across multiple courses to solidify understanding and promote mastery over time. Content prioritization asks us to clearly define learning objectives, focus on foundational concepts that underpin advanced work, and perform relevance analysis to prioritize material that aligns with industry standards or real-world applications, improving career readiness and academic engagement. Course-level alignment requires progressive difficulty, so introductory classes build towards advanced work, matching assessments to expected competencies at each level, and maintaining a pedagogical balance that blends theory and practice appropriate to the course's academic stage. Integration across disciplines encourages interconnectivity by highlighting shared themes, designing collaborative projects that bring students from different backgrounds together, and promoting skill synergy so transferable techniques can be applied across varied fields for a more holistic education. Prerequisite courses protect foundational knowledge by ensuring students acquire essential skills before advancing. Structure learning to build critical competencies progressively and prepare learners so they can engage successfully in more complex, higher-level coursework without gaps in understanding. Scaffolding learning experiences introduces concepts gradually with incremental support, integrates resources like guided tutorials and peer collaboration to reinforce understanding, and places learning checkpoints to assess readiness before moving on to more demanding material. Creating pathways for student progression means offering flexible routes that match diverse interests and learning styles, tracking milestones to mark credit and skill achievement, and providing interdisciplinary opportunities that broaden adaptability for students exploring complex career paths. Balancing formative and summative assessments keeps learning on track by using low-stakes activities like quizzes and reflections to give ongoing feedback, while summative evaluations such as final projects measure overall competency, all within a supportive approach that fosters incremental skill growth. Competency measurement strategies should align assessment tools with learning outcomes, use authentic tasks like projects or portfolios to reflect real-world mastery, and employ pre- and post-testing to track growth and refine instructional approaches based on evidence of student progress. Closing the feedback loop relies on actionable critique that offers specific steps for improvement, iterative refinement where faculty use assessment data to update materials and teaching, and stakeholder engagement that includes students in feedback discussions to enhance transparency and ownership of learning. Addressing diverse learning needs requires adaptive course design that meets varied levels of prior knowledge, incorporates multiple teaching modalities to reach different learning styles, and provides extra support resources such as tutoring or supplemental materials so all students can stay on track. Managing faculty collaboration means confronting communication gaps that cause inconsistencies, acknowledging time constraints that limit alignment work, and navigating differing priorities or pedagogical philosophies so departments can build a cohesive curriculum through shared goals and coordinated effort. Adapting to technological advancements involves staying current with evolving digital tools through regular training, tackling integration challenges so technology complements course objectives effectively, and addressing digital equity to ensure all students have fair access to the resources required for meaningful learning. In mapping general education requirements, aim for curricular alignment, so foundational courses support institutional goals like critical thinking, broaden students' exposure across disciplines to cultivate well-rounded graduates, and organize course progression so foundational and advanced levels build coherently on essential skills and concepts. Sequencing in STEM programs benefits from clear prerequisite structures where courses like calculus or chemistry prepare students for major specific work, early hands-on integration with labs and research to link theory and practice, and interdisciplinary approaches that add data analysis or technical communication to expand students' career-ready skill sets. Designing a competency-based program begins by defining core competencies, key skills, and knowledge needed for success, aligning curriculum with those outcomes so courses contribute directly to mastery, and incorporating formative and summative assessment strategies to measure progress and ensure students demonstrate the required competencies. Thanks for viewing this overview of course mapping and sequencing. We hope these principles and examples give you practical ideas to strengthen curriculum alignment, support student progression, and create coherent learning pathways that lead to measurable outcomes and real-world readiness.